Hi everyone. Today we're going to study convolution theorem on inverse Laplace transform. If Laplace inverse of the function capital F of s, this is equal to the function small f of t, and Laplace inverse of the function capital G of s, and this is equal to the function small g of t. Then, Laplace inverse of the product capital F of s times capital G of s. This is equal to the definite integral from 0 to t of the function small f of u times the function small g of t minus u, then du. Example 1. Find the inverse Laplace transform of s squared over the square of s squared plus 1 using convolution theorem. Let us copy our formula for the convolution theorem. Then let us write the notation Laplace inverse of this function. We're going to split this function into two such that we have like this. We take the first function to be the f of s and the second function to be the g of s. Then for step 1, let's evaluate Laplace inverse of the function f of s. Later, the answer will be and this is equal to the function small f of t. And then let us evaluate this f of t with respect to u. So we have f of u. Let us now evaluate Laplace transform Laplace inverse of the f of s, and that is this s over s squared plus 1. The answer here is cosine t. This is now our f of t. Let's evaluate this with respect to u. So we have this cosine u. Then for step 2, let's evaluate Laplace inverse of the function g of s. This is our function. And the answer here will be the function small g of t. Then later, we will evaluate this function into g of t minus u. Let us now evaluate the Laplace inverse of s over s squared plus 1. This is equal to cosine t. And this cosine t is our g of t. Let's evaluate this with respect to t minus u. So we have now cosine of the quantity t minus u. Then step 3. Let's use now the convolution. Let us use now and evaluate the definite Let us now evaluate using convolution theorem. We have now this definite integral. Let us substitute the corresponding values. The f of u is this cosine u, and the g of t minus u is this cosine of t minus u, then du. Remember that we have an identity like this, that cosine A times cosine B is equal to 1/2 of the quantity cosine of A plus B plus the cosine of A minus B. In our function here, the value of A is u and the value of B is the t minus u. Applying this formula, we have now like this. We put 1/2 or the constant outside the integral sign. So we have now this cosine of A plus B, which means the u plus t minus u. when we simplify, we have t plus the cosine of a minus b, that is u minus t minus u. Simplifying, we have now this 2u minus t, then du. At this point, we will now take the integral of each of the function, beginning with cosine t. Take note here that we are going to take the integral of cosine t with respect to du, which means the cosine t here is considered as constant, which means the integral is cosine t times u plus integral of cosine of the quantity 2u minus t is now sine of 2u minus t all over 2. At this point, we're going to simplify by multiplying the 1/2 to each term inside the grouping symbol. So we have now this 1/2 times u times cosine t plus the sine of the quantity 2u minus t all over 4. Then we will take the next is we're going to evaluate now with respect to limits. We have now the two groups here. The first group is this function evaluated with respect to t, which means we change the u with the t. It means we change the u value. It means we change the u variable with t, just like what we see in here. Then minus the second group is the minus this second group is the evaluation of this function with respect to 0. Again, we change the variable u by 0 as we see here. Then let us simplify further. In the second group, we have the 0 here as a factor. It means the whole product can be cancelled out into 0. Then let us simplify one by one. The first term here, we will just copy, plus the second group will be sine of the quantity 2t minus t, where we can simplify as t, all over 4, minus the second group now is the sine 2 times 0 will be 0, and then we have here minus t. So we have sine of negative t all over 4. Let us simplify this sine of negative t. Remember that we have an identity that says sine of negative t is equal to negative of sine t. Substituting this value here, we have it here now. It becomes like this. Then let us simplify further. This negative and negative becomes positive. We can see that we can combine this sine t over 4 plus the sine t over 4. Let's combine and simplify into sine t over 2. There is a common factor in the first group and the second group, and that is 1/2 that we can factor it out. So the final answer, 1/2 of the quantity t cosine t plus sine t. Example 2, evaluate Laplace inverse of s all over the square of s squared plus a squared using convolution theorem. We write our formula for the convolution theorem. We copy our problem down here, and we're going to split this into two functions. One is s over s squared plus a squared times 1 over s squared plus a squared. When we compare the numerators of the two functions, here is s, the other is 1. It means s having a higher degree, we treat this as the f of s. The other function will be the g of s. Then step 1. Let's evaluate Laplace inverse of f of s. The answer will be the function f of t. Later, we're going to evaluate with respect to u. So we have f of u. Let's begin now with the Laplace inverse of f of s. That is s over s squared plus a squared. The answer here is cosine at. This is our f of t. Let's evaluate this with respect to u. So f of u is equal to cosine of au. Then step 2. Evaluate Laplace inverse of g of s. Later the answer will be g of t. We will evaluate this, and then we will evaluate this g of t into t minus u. So we have g of t minus u here. Let's begin now to evaluate Laplace inverse of the g of s. That is, this is our g of t. When we evaluate this with respect to t minus u, we have now the sine of a. Simplify this further into sine of the quantity at minus au all over that denominator a. Then we go to step 3. Let us use now the definite integral formula of convolution theorem. Let us substitute the corresponding values. F of u is this cosine au multiplied by the g of t minus u. That is this value, sine of the quantity at minus au all over a, then du. When we combine the cosine and sine, normally we put the sine in the beginning after followed by the cosine. And this constant a integral from 0 to t of the function sine of at, the cosine of au, then the du. Remember that we have a formula for sine a times cosine b. This is equal to 1/2 times the quantity sine of the sum a plus b plus the sine of the difference a minus b. Take note that a here is the value at minus au, and the b is this au. Let's apply this formula in our function here. So we have now this 1 over a times 1 over 2 times the definite integral from 0 to t of the function sine of at minus au plus the sine of the quantity at minus au. Then let us simplify these terms inside the grouping symbols respectively. So we have now like this, 1 over 2a times the definite integral from 0 to t. We have now the sine of at plus the sine of at minus 2au, then du. Let us now evaluate the corresponding functions. The sine at here is to take the integral of this sine at with respect to du. When we get the integral of the sine at with respect to du, we will take this sine at as a constant, which means the integral will be sine at multiplied by u. Then, the integral of sine of at minus 2au. It will be negative of the cosine at minus 2au all over negative 2a. Simplifying further, we're going to multiply this 1 over 2a to each. So in the next line, we have like this. 1 over 2a times u times sine of at plus the cosine of the quantity at minus 2au all over 4a squared. Let us now evaluate this with respect to limits. We have two big groups. The first group here is the evaluation of this function with respect to t, which means we change all variable u with respect to t, as we see here, with respect to 0. Again, we change all the variable u by 0. Let us now simplify one by one. In the second group, we have this 0 in the